Hello, so in this video we're going to understand about the Ferris wheel problems, how to solve them. A Ferris wheel moves with a constant speed and completes one rotation every 40 seconds. The wheel has a radius of 12 meter and its lowest point is 2 meter above the ground. The height of the chair on the Ferris wheel above ground can be modeled by the function h of t bt plus c, where t is the time in the seconds. Find the value of a, b, c we need to find, and the chair first reaches a height of 20 meter above the ground after p seconds. We need to find the angle and the value of p. Okay, let's gather the information given in the question and we'll try to draw the graph. So here we have a Ferris wheel. The motion of the Ferris wheel is periodic, and any periodic function can be any periodic motion can be modeled by using sine or cosine function. We board the Ferris wheel from a certain height, right? The Ferris wheel does not touch the ground. The height at its lowest point above the ground is 2 meter, and the radius of the Ferris wheel is 12 meter. So its center will be at the 14 meter above the ground, and its top of the and the top of the Ferris wheel will be, cos 12 is the radius, so 24 will be diameter, and it's 2 meter above the ground, so its maximum height above the ground will be 26 meter. So now the Ferris wheel, in 40 seconds the Ferris wheel starts from 2 meter above the ground. In next 20 seconds it reaches to the top and then comes back to its lowest point. Now what is a, b and c here in this function? A is the amplitude of the graph. B is the horizontal stretch or compression. Stretch or compression. And C is the vertical shift. C will be the vertical shift. Now how do we find them? So either you should be master at constructing the graph, sketching the graph, or you can follow this one. Like if you want to get the amplitude in the Ferris wheel problems, subtract the maximum and minimum height of the Ferris wheel above the ground and divide it by 2. So the maximum height above the ground is 26, the minimum is 2, divided by 2, that would be 12. So the 12 meter is the amplitude. And the vertical shift C, to get the vertical shift where the equilibrium line lies, so the C will be the maximum height of the Ferris wheel above the ground plus minimum over 2. So that will be 26 plus 2 over 2. That will be 14 meters. So this is the vertical shift is 14. The amplitude is 12. And what about the B, horizontal stretch or the compression? The horizontal stretch or compression we can get by 2 pi over the time period. The time period, it means the time taken to complete one rotation. So that is 2 pi and that's 40 seconds. So over 40 you get pi over 20. Pi over 20 is B, right? We now try to draw the graph. See, the Ferris wheel is 2 meter above the ground. So let's take the point 2 here. Its its maximum height, its top is at 26 meter above the ground. So let's take 26 here. And its equilibrium line is at 14. So let's take 14 meter here, and See, the motion of the Ferris wheel starts from 2 meter above the ground, and after 40 seconds it comes back at the same position. In between, at 20 second it will be on top, and it will be at 14 in between the time period of 0 to 20 and 20 to 40. And when you join these points, you get a sinusoidal curve where you can see the amplitude of the graph here from 14 to 26 is 12. And now we can function also, this is a cosine graph, so any sinusoidal curve is the sinusoidal curve. It means it can be modeled by using sine or cosine function, but here in the question it is given that it's cosine function. So if you compare with the cosine function graph, that is something like this, that start from its maximum point. But because it's starting from the minimum point, so you can say it's a negative cosine function. So we can write it negative as a negative cosine function. So our function would be h of t will be minus 12, because a is 12, cos b, the value of b is pi over 20, pi over 20t, plus c, the vertical shift is 14. Okay, so this is the function. And now we have to find the angle that the chair has rotated when the height of the chair was 20 meter above the ground. Okay, so we use this function to get these values. So let's say it was at 20 meter above the ground, negative 12 cos pi over 20 t plus 14. So we can get cos pi over 20 t will be equal to 20 minus 14 over minus 12. That will be 1 over 2. That will be negative 1 over 2. And cos is negative in the second quadrant. So we can write this as cos pi minus pi over 6, pi over 3. Okay, so therefore we can say the pi over 20, so the angle is, so according to the question, the chair will be at p seconds, so we replace the t with the p, because after p second it will be at this point. So we can say the angle will be, so the angle will be at that time, and if you further simplify, this will be 2 pi over 3. So the angle when the chair will be 20 meter above the ground will be 2 pi over 3. And now how do we find the value of p? So if you compare, pi over 20, p will be 2 pi over 3. So p will be 2 pi over 3 times 20, and pi you can cancel out. So this is 40 over 3. So we can get 40 over 3. That's 13.3 seconds. 33 seconds. That's 13.33 seconds, right? So this is the answer, and hope you understood the problem, and we can discuss more and more problems in the coming videos about the Ferris wheel. Thank you so much.